Welcome back to the second part of building the counter-terrorist in Unity. And the AI system that we got working so far is working just like this. Take a look. So we got the AI that spins only in one direction when they sense a obstacle in front of them, which is not ideal. So now let's work on fixing that by making it rotate into a random direction so it can either go right or left. Okay, let's open up the script and let's go back to our old roam function. So in here we're going to add some more lines. First, let's add a function that randomizes the direction. So to randomize directions, we are going to need a random function, and to get a random function, we obviously need system collections. We're going to make another function. We're going to call it public void set direction. It's going to take no parameters, and inside we are simply going to set the direction. So the direction is equal to random dot range. We're going to range from 0 to 2, and now we have a 50-50% chance. So if that returns 1, we are going to return a true value, and if that returns a more than 1 or 2 or 0, we're going to return a false value. We don't have a set direction. As we can see, the compiler is yelling at us. So let's create a set direction private variable. So we're going to say private boolean direction. Make sure to name your functions differently than your variables. And now we're going to need another function to know if we've already set the direction. So we're going to define a new public or a private boolean. So we're going to say private boolean, and we're going to name it direction flag. This flag will help us know if we'll already. So to do that, we are going to say flag is equal to true. So every time this function gets called, we set the flag to true. That means we have already used this function once. So now in order to use this function, we are going to have to know if we have hit a obstacle. So if we hit a obstacle, we know that this forward movement will tell us. So if we do stop walking, first we're going to delete this mouse Y, and we're going to do a filter. So if forward movement is equal to 0, that means we've hit something. So if we did, we're going to do another function, and we're going to ask if the direction flag is equal to false. Another way of saying direction flag is equal to false is by simply adding a exclamation mark right there. So if we didn't use this flag, we're simply going to use it. So set direction, and now we have used this flag. So now we have a direction of true or false. Now all that's left for us is to use it. So in order to use it, we are going to take this obstacle distance and we are going to randomize it. So we're going to ask obstacle distance is equal to, if the direction flag, then we are going to tell it to keep moving that direction, so obstacle distance. And if we didn't, we are simply going to reverse it, so minus obstacle distance. And there we have our function. Now let's work in the else statement. We are going to tell it if it didn't move, we can carry on moving forward. Obviously, we are going to reset the directional flag to false. So we're going to say direction flag is equal to false. We're going to also tell the mouse Y to be equal to 0. And one thing I forgot up here is to actually tell the mouse to move around. So I'm going to say mouse Y is equal to obstacle distance. I've done a slight mistake in here. I'm using directional flag to change the actual direction. I'm just going to delete that, and I'm going to use direction. And now the game should be running fine. And there it is. The AI gets stuck in some places, in quite a lot of places actually. And the problem is that it stops turning at the very last moment. In other words, it's not turning enough. So let's make it turn a little bit more than it should. I've defined a local maximum distance. So all this local maximum distance will do is hold the maximum distance that we give it from the beginning. And the reason for that is because we want to increase the distance while we're turning. And doing that, we can turn a little bit more than we need to. to use that, we're going to go back into our set direction function, and we're going to set camp maximum distance is equal to camp maximum distance slash 2. So we're adding 50% more to the maximum distance. And let's not forget to bring this down to 5 after we've used it. So into the else statement, we camp distance is equal to local distance. And now our system should run flawlessly, kind of flawlessly, because if we want to run flawlessly, we need more than one sensor. Okay, now they're turning more than they need to, and therefore they can carry on walking around. Okay, let's add the last function that I promised to add in the previous video, and that is the camping function. Somewhere up here we are going to define camp points. To define camp points, I'm going to use them as transforms. So public transform array of transforms camp point transforms. To load this array, I'm going to use the start method, and in the start method I'm going to load it by saying camp point transforms is equal to find objects of type, and now I'm going to go back into camp points and I'm going to copy the name of that script and I'm going to paste it in here. And now we have a slight problem that the compiler is telling us. So we cannot transform camp point into transforms, and that is easily fixed by using another array. So we're going to say public camp points array of camp points, and we're going to name it just camp point. And now we're going to copy camp points and paste it in here, and now we have the full array loaded in here. So since we have a camp point, we don't necessarily need an actual transform of it. You might have guessed it, we need another boolean function. So we're going to define a new boolean. We're going to call it public boolean camping. It's going to be defaulted to false, obviously. And we're going to simply ask if we are not camping, we can keep roaming around. And else, we are going to tell it to simply camp. So I'll create another method. I'm going to call it obviously camp public void camp. This will also take no parameters. And to camp, we need some new variables. Firstly, we need a maximum distance that we can detect a camp point. So let's define that. Let's say public load camp point distance. And now to detect the camp point, we are going to use a standard for loop. The for loop will go through the whole entire array. And in here we ask if vector3 dot distance from the transform dot position into camp points in the index of I dot transform dot position is less than or equal to camp maximum distance, and this means that we have found the nearest camp point distance. And the last thing for us to do is to tell it to set the destination to there. So to set the destination, we are going to copy this line from here. We're going to tell the agent to set destination for us. So we're going to paste it back in here, set destination. And instead of the controller.transform.position, we are obviously going to use the camp point in the index of I.transform.position. Okay, so I had a little bit of trouble with my code, and this is the final code that I made to work. What I've added is this transform.destination, because using a vector3 would not work for some reason, so I'm using a transform destination. And into the if statement where I'm asking if I'm camping or not, I've added another if statement that checks if we've already reached that destination. And if we have, we set the vertical input to 0. And then down here, I've set the mouse Y to 0, the forward movement to 0. And the reason for that is because the agent takes care of everything. So this is the code. If you can't keep up with me writing the code, don't worry about it. In a couple of days, I'll be releasing the full project of this game, so be on the lookout for that. And this is the code working with the camping spots that I have implemented. So take a look. Okay, here is our bots just roaming around. And if they get too close to a camping spot, as we did in here, now this guy will go into that spot and simply stay there. Right there. There it is. So a flaw for that now is obviously that multiple bots will go into the same spot, which is a little bit of a worry, but I'll fix that off camera. So thank you for watching. I hope you liked it. I hope you enjoyed it, and I'll see you in the next videos.